Okay, sorry for the delay, everybody. So, chapter 6 tonight. This is a pretty good chapter. 5 sections, 107 questions, and only 43 pages. So, amplifier characteristics and designs, oscillators and frequency synthesis, mixers and modulators, detectors, demodulators, digital signal processing, and software-defined radios, filter types and characteristics, and impedance matching in power supplies. So our first section 1 is on amplifiers. 6 questions. Oh shucks, I forgot to add in figure 7-1. Dang it. What is the purpose of R1 and R2? And I'm sorry I didn't add in the, let me see if I can just add it here. Darn it. Thought I got all of those. And this is the very first one. E7. E7-1 and E7B. Oh, goodness. Okay. Let's see if this is going to work or not. Yeah, that's really hard. So on page 13-68, sorry folks, I thought I got all of these. Well, we're just going to have to go through it. It's the voltage divider bias. Gosh, I hope I don't have a ton of those. Oh, it says 10, 11, and 12. You know what?
It's
Let
just
me.
3 figures is all. There's just 3
Yep.
of them.
Yep. So, purpose of R3 in figure 7-1, which I didn't get on that one either, is for the self bias, and that's in page 6-3. And the last one, what type of amplifier circuit is shown in E7-1? That is the common emitter. Okay. Which of the following describes an emitter follower or common collector amplifier? A 2-transistor amplifier with the emitter sharing a common bias resistor. B, a differential amplifier with both inputs fed to the emitter of the input transistor. Or C, an OR circuit with only one emitter used for output. Or D, an amplifier with a low impedance output
Yeah,
that
I can hear you.
Okay, good. Last one is D, an amplifier with a low impedance output.
Well, I'm sitting here watching it.
Hello, Jerry.
Yeah, I'm getting a conversation from somebody. So I'm not sure why I've tapped into 2 different meetings here.
Oh, that's weird. It should only be one.
Yeah, I'm sorry. I was having trouble getting logged in. Okay, I will just mute myself.
Okay. So the correct answer on this one, wow, I'm just
Delta.
batting 1,000. Delta, an amplifier with a low impedance output that follows the base input voltage. What is one way to prevent thermal runaway on a bipolar transistor amplifier? A, neutralization. B, select transistors with high beta. C, use a resistor in series with the emitter. or D, all of these choices are correct?
Charlie.
Charlie.
Charlie is correct. Use a resistor in series with the emitter. What is a characteristic of a grounded grid amplifier? You know what? My own speakers are giving me feedback. Sorry. Okay. What is a characteristic of a grounded grid amplifier? A, high power gain. B, high filament voltage. C, low input impedance. Or D, low bandwidth?
Charlie.
Charlie is correct. A low input impedance. Okay, next section is on op amplifiers. 10 questions. What is a typical output impedance of an op amp? A, very low. B, very high. C, 100 ohms. Or D, 1000 ohms?
Alpha.
Alpha.
Alpha is correct, very low. What is the typical input impedance of an op amp? A, 100 ohms. B, 1000 ohms. C, very low. Or D, very high?
Delta.
Delta.
Delta is correct. What is meant by the term op amp input offset voltage? A, the output voltage of the op amp minus its input voltage. B, the difference between the output voltage of the op amp and the input voltage required in the immediately following stage. Or C, the differential input voltage needed to bring an open loop voltage to 0. Or D, the potential between the amplifier input terminals of the op amp in an open loop condition.
Charlie.
Charlie.
Charlie is correct. What is the gain bandwidth of an operational amplifier? A, the maximum frequency for the filter circuit using that type of amplifier. B, the frequency at which the open loop gain of the amplifier equals 1. C, the gain of the amplifier at a filter's cutoff frequency. Or D, the frequency at which the amplifier's offset voltage is 0.
Bravo.
Bravo is correct. Yay, I added the figure this time.
All right.
What magnitude of voltage gain can be expected from the circuit in figure E7-3 when R1 is 10 ohms and RF is 470 ohms? A, 0.21, B, 94, C, 47, or D, 24?
Charlie.
Charlie is correct. 47. How does the gain of an ideal operational amplifier vary with frequency? A, it increases linearly with increasing frequency. B, it decreases linearly with increasing frequency. C, it decreases logarithmically with increasing frequency. Or D, it does not vary with frequency.
Delta.
Alpha.
Delta is correct. It does not vary with frequency. What will be the output voltage of the circuit shown in figure E7-3 if R1 is 1000 ohms, RF is 10,000 ohms, and 0.23 volts DC is applied to the input? A, 0.23 volts, B, 2.3 volts, C, negative 0.23 volts, or D, negative 2.3 volts?
Delta.
Delta.
Delta is correct, negative 2.3 volts. What absolute voltage gain can be expected from the circuit in figure E7-3 when R1 is 1,800 ohms and RF is 68 kiloohms? A, 1, B, 0.03, C, 38, or D, 76?
Charlie.
Charlie is correct, 38. What absolute voltage gain can be expected from the circuit in figure E7-3 when R1 is 3,300 ohms and RF is 47 kiloohms? A, 28, B, 14, C, 7, or D, 0.07?
Bravo.
Bravo is correct, 14. What is an operational amplifier? A high gain direct coupled differential amplifier with a very high input impedance and a very low output impedance. B, a digital audio amplifier whose characteristics are determined by components external to the amplifier. C, an amplifier used to increase the average output of frequency modulated amateur signals to the legal limit. Or D, an RF amplifier used in UHF and microwave regions?
Alpha.
Alpha.
Alpha is correct. Comparators, 2 questions. Now we're getting into the little ones that have a couple here and a couple there. What is the function of hysteresis in a comparator? A, to prevent input noise from causing unstable output signals. B, to allow the comparator to be used with AC input signals. C, to cause the output to change states continually. Or D, to increase the sensitivity?
Alpha.
Alpha is correct, to prevent input noise from causing unstable output signals. What happens when the level of a comparator's input signal crosses the threshold? A, the IC input can be damaged. B, the comparator changes its output state. C, the comparator enters latch up. Or D, the feedback loop becomes unstable. I heard a B out there. The correct answer is B,
Bravo,
Baker.
yeah.
Bravo. The comparator changes its output state. Classes of operation, 7 questions. For what portion of the signal cycle does each active element in a push-pull class A-B amplifier conduct? A, more than 180 degrees but less than 360 degrees. B, exactly 180 degrees. C, the entire cycle. Or D, less than 180 degrees.
Alpha.
Alpha.
Alpha is correct. What is a Class D amplifier? A type of amplifier that uses switching technology to achieve high efficiency. B, a low power amplifier that uses a differential amplifier for improved linearity. C, an amplifier that uses drift mode FETs for high efficiency. Or D, a frequency doubling amplifier.
Alpha.
Alpha is correct. A type of amplifier that uses switching technology to achieve high efficiency. Which of the following components form the output of a Class D amplifier circuit? A low-pass filter to remove switching signal components. B, a high-pass filter to compensate for low gain at low frequencies. Or C, a matched load resistor to prevent damage by switching transients. Or D, a temperature compensated resistor to improve linearity.
Alpha.
Alpha.
Alpha is correct. Where is the load line of a Class A common emitter amplifier would bias normally be set? A, approximately halfway between saturation and cutoff. B, where the load line intersects the voltage axis. C, at a point where the bias resistor equals the load resistor. Or D, at a point where the load line intersects the zero bias current curve.
Alpha.
Alpha.
Alpha is correct, approximately halfway between saturation and cutoff. Which of the following amplifier types reduces even order harmonics? A push-push, B, a push-pull, C, a Class C, or D, a Class AB?
Bravo.
Bravo.
Bravo is correct, a push-pull. Which of the following is a likely result when a Class C amplifier used to amplify a single sideband phone signal? A, reduced intermodulation products. B, increased overall intelligibility. C, signal inversion. Or D, signal distortion and excessive bandwidth.
Delta.
Delta.
Delta is correct, signal distortion and excessive bandwidth. Why are switching amplifiers more efficient than linear amplifiers? A, switching amplifiers operate at higher voltages. B, the power transistor is at saturation or cutoff most of the time. C, linear amplifiers have high gain resulting in higher harmonic content. Or D, switching amplifiers use push-pull circuits.
Bravo.
Bravo.
Bravo is correct. The power transistor is at saturation or cutoff most of the time. Now we'll go into distortion and intermod. What is the effect of intermodulation products in a linear power amplifier? A, transmission of spurious signals. B, creation of parasitic oscillations. C, low efficiency. Or D, all these choices are correct.
Alpha.
Alpha is correct, the transmission of spurious signals. Why are odd order rather than even order intermodulation distortion products of concern in a linear power amplifiers? A, because they are relatively close in frequency to the desired signal. B, because they are relatively far in frequency from the desired signal. C, because they invert the sidebands causing distortion. Or D, because they maintain the sidebands, thus causing multiple duplicate signals.
Alpha.
Alpha.
No.
Alpha is correct, because they are relatively close in frequency to the desired signal. Do a couple on signal processing instability. What can be done to prevent unwanted oscillations in an RF power amplifier? A, tune the stage for maximum SWR. B, tune both the input and output for maximum power. C, install parasitic suppressors and or neutralize the stage. Or D, use a phase inverter in the output filter.
Charlie.
Charlie.
Charlie is correct. Install parasitic suppressors and or neutralize the stage. How can RF power amplifier be neutralized? A, by increasing the driving power. B, by reducing the driving power. C, by feeding a 180-degree out-of-phase portion of the output back to the input. Or D, by feeding an in-phase component of the output back to the input.
Charlie.
Charlie is correct, by feeding a 180-degree out-of-phase portion back to the input. 6 questions for RF oscillators. What are 3 oscillator circuits used in amateur radio equipment? A, Taft, Pierce, and negative feedback. B, Pierce, Fenner, and Bean. C, Taft, Hartley, and Pierce. D, Colpitts, Hartley, and Pierce.
Delta.
Delta is correct. Boy, they just
Sounds
throw
like
some
law firms.
real winners in there. Talk about distracting. Oh goodness.
Wasn't Pierce Taft's vice president too?
Yeah, I think so. Something in there. Something with presidents. When I was reading it, I'm going, this sounds like president stuff. I don't, who's Bean? Oh goodness. How?
Bean it's Merrill Lynch, Pierce, Fenner, and Bean.
Okay. I was thinking of the Mr. Bean comic guy from England. How is positive feedback supplied in a Hartley oscillator? A, through a tapped coil. B, through a capacitive divider. C, through link coupling. Or D, through a neutralizing capacitor.
Alpha.
Alpha is correct, through a tapped coil. How is positive feedback supplied in a Colpitts oscillator? A, through a tapped coil. B, through link coupling. C, through a capacitive divider. Or D, through a neutralizing capacitor.
Charlie.
Colpitts uses
Charlie.
through a capacitive divider. Colpitts and capacitive divider. How is positive feedback supplied in a Pierce oscillator? A, through a tapped coil. B, through link coupling. C, through neutralizing capacitor. Or D, through a quartz crystal.
Delta.
Delta uses the quartz crystal, correct. Which of the following oscillator circuits are commonly used in VFOs? A, Pierce and Zener. B, Colpitts and Hartley. C, Armstrong and DeForest. Or D, negative feedback and balanced feedback.
Bravo.
Bravo is correct. Colpitts and Hartley. Which of the following is a technique for providing highly accurate and stable oscillators needed for microwave transmission and receptions? A, use a GPS signal reference. B, use a rubidium stabilized reference oscillator. C, use a temperature controlled high Q dielectric resonator, or D, all of these choices are correct?
Alpha.
Alpha.
Delta.
Delta.
Delta is the correct. All of these are correct. You can use a GPS, a rubidium, or a high or temperature controlled high Q. So all of these are correct. Crystals for oscillators, 3 questions. What is the equivalent circuit of a quartz crystal? A, motational capacitance, motational inductance, and a loss resistance in series, all in parallel with a shunt capacitor representing electrode and stray capacitance. B, motational capacitance, motational inductance, loss resistance, and a capacitor representing electrode and stray capacitance all in parallel. Or C, motational capacitance, motational inductance, loss resistance, and a capacitor representing electrode and stray capacitance all in series. Or D, motational inductance and loss resistance in series, paralleled with motational capacitance and a capacitor representing electrode and stray capacitance. Wow, that was a real tongue twister there.
Alpha.
Alpha.
The correct answer is alpha, and no, I'm not going to repeat all of that. Whew. Which of the following, and I wonder, no, you can't really tell, is that the longest answer? Well, they're
Oh,
good grief. Okay, which of the following is an aspect of the piezoelectric effect? A, mechanical deformation of material by the application of a voltage. B, mechanical deformation of material by the application of a magnetic field. Or C, generation of electrical energy in the presence of light. Or D, increased conductivity in the presence of light.
Alpha.
Alpha.
Alpha is correct.
Hey, can you go back?
Yep.
I learned it the other way around, that you would, that deforming the mechanical would create the voltage.
You know what, Anthony, I actually kind of remember that same way, that by deforming it, it would create the application.
Yeah, I used to work on strain gauges and weighing systems, and that's how they worked. You put a
Yeah.
crystal, the sensor on there, and you would stress the bridges of the strain gauge, and the voltage would come out. But the voltage
That's-
wouldn't change the structure of the. You had to pump a lot of voltage in there to do anything to the metal.
Yeah.
But maybe we're talking about microscopic levels where it's not that big of a deal.
Yeah, and I'm not 100% sure, other than looking at what it says on page 615. Yeah, so on that page it says quartz is a natural piezoelectric material with the ability to change mechanical energy such as pressure or deformation into electrical potential or voltage, and vice versa.
Yeah.
So this property is
Okay.
known. So yeah,
So if you, I guess that's why you put electricity in a crystal, it could vibrate differently.
yeah. I actually learned like you from back in the late 70s. I thought it was deforming it created the voltage. Well, that's why I'm here to learn something new. It's vice versa, so it can do either one. If you apply it, it vibrates. If you deform it, it creates voltage. Which of the following must be done to ensure that a crystal oscillator provides the frequency specified by the crystal manufacturer? A, provide the crystal with a specific parallel inductance. B, provide the crystal with a specified parallel capacitance. C, bias the crystal at the specified voltage. Or D, bias the crystal at a specified current.
Bravo.
Correct answer is bravo. Provide the crystal with a specified parallel capacitance. Microphonics and thermal drift. 3 questions. A, what is microphonic? A, an IC used for amplifying microphone signals. B, distortion caused by RF pickup on the microphone cable. C, changes in oscillator frequency due to mechanical vibration. Or D, excess loading of the microphone by an oscillator.
Charlie.
Charlie is correct. Changes in an oscillator frequency due to mechanical vibration. How can an oscillator's microphonic responses be reduced? A, use NP0 capacitors. B, or is that NPO capacitors? B, reduce noise on the
It's 0.
0. Oop. Reduce the noise on an oscillator's power supply. C, increase the bias voltage. And if you saw me click ahead, mechanically isolate the oscillator circuitry from its enclosure.
Alpha.
Delta.
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 I accidentally clicked and nobody caught that. Delta is correct. Mechanically isolate the oscillator circuitry from its enclosure. Which of the following components can be used to reduce thermal drift in crystal oscillators? A, NP0 capacitors. B, toroidal inductors. C, wire wound resistors. Or D, non-inductive resistors.
Alpha.
Alpha is correct, and I learned something new again. NP0 capacitors. Direct digital synthesizers, DDSs. 3 questions. What type of frequency synthesizer circuit uses a phase accumulator, lookup table, digital to analog converter, and a low-pass anti-alias filter? A, a direct digital synthesizer. B, a hybrid synthesizer. C, a phase-locked loop synthesizer. Or D, a diode switching matrix synthesizer.
Alpha.
The correct answer is alpha, a direct digital synthesizer. What information is contained in the lookup table of a direct digital synthesizer, or DDS? A, the phase relationship between the reference oscillator and the output waveform. B, amplitude values that represent the desired waveform. Or C, the phase relationship between a voltage-controlled oscillator and the output waveform. Or D, the frequently used receiver and transmitter frequencies. The correct answer is Baker. Bravo. Amplitude values that represent the desired waveform is in your lookup table. What are the major spectral impurity components of a direct digital synthesizer? A, broadband noise. B, digital conversion noise. C, spurious signals at discrete frequencies. Or D, the Nyquist limit noise?
Charlie,
Charlie is correct. Spurious signals at discrete frequencies. Phase lock loops. 2 questions. What is a phase lock loop circuit? A, an electronic servo loop consisting of a ratio detector, reactance modulator, and a voltage-controlled oscillator. B, an electronic circuit also known as a monostable multivibrator. C, an electronic servo loop consisting of a phase detector, a low-pass filter, a voltage-controlled oscillator, and a stable reference oscillator. Or D, an electronic circuit consisting of a precision push-pull amplifier with a differential input.
Charlie,
Charlie is correct. Which of these functions can be performed by a phase lock loop? A, wideband AF and RF power amplification. B, comparison of 2 digital input signals, digital pulse counter. C, photovoltaic conversion, optical coupling. Or D, frequency synthesis and FM demodulation.
Delta,
The correct answer is delta, frequency synthesis and FM demodulation. Okay, thought I had another email plopping in there, sorry. Mixers, 2 questions. How is power supplied to the most common type of MMIC? A, through a resistor and or RF choke connected to the amplifier output lead. B, MMICs require no operating bias. Or C, through a capacitor and RF choke connected to the amplifier's input lead. Or D, directly to a bias voltage or VCC in lead.
Jim, this is the wrong chapter.
From the
isn't it?
last week's chapter.
Oh, yeah, you're right.
Should be E7.
Hang on, sorry.
It's okay.
So, remove, yeah, right. E6. E08. I hope I didn't do a whole string of these. Okay. Uh-oh, I think I did, huh? Because that's
just 2.
Yeah.
okay. Yep. Go back here real quick. Mixer section. Cut and paste the wrong one. Mixers. Wrong. Should be 7, not 6. Okay, sorry about that. Okay, gosh, I hope I didn't do that through this section here. Modulators, 7E07. Oh, I did it again. Quality control.
It's a huge job, Jim.
Yes, it is.
Okay, modulators.
Jim, didn't you put that in there deliberately just to test our knowledge, make sure that we're on track?
Make sure we're paying attention.
Well, I'm glad you guys are paying attention because and I went through this and this, I caught one of them before. I'm surprised I didn't catch this one. E04. Well, you get instant passes on those. Now let's hope I didn't do this. Oh goodness. Yeah, I'm worried already. E7, E01. Ah, here we go.
Ah,
I'm back to regular.
Mhm.
Which of the following can be used to generate FM phone emissions? A balance modulator on the audio amplifier. B, a reactance modulator on the oscillator. C, a reactance modulator on the final amplifier. Or D, a balance modulator on the oscillator. To generate FM phones, we use a reactance, bravo, a reactance modulator on the oscillator. What is the function of a reactance modulator? A, to produce PM signal by using an electrically variable resistance. B, to produce AM signals by using an electrically variable inductance or capacitance. C, to produce AM signals by using an electrically variable resistance. Or D, to produce PM or FM signals by an electronically variable inductance or capacitance.
Delta.
Correct answer is delta, to produce PM or FM signals by using an electrically variable inductance or capacitance. Preemphasis and deemphasis. Oh, goodness. I messed another section up. Good grief, Charlie Brown. Preemphasis. See, I was using the book and I was cutting and pasting these particular sections, and I got too caught up in that. So E7, E05, and E06. Good grief. Okay, so these are both wrong. Okay, hopefully I did do a whole sequence again. E7, E03. Yay,
That looks good.
that looks good. What is a frequency discriminator stage in an FM receiver? A, an FM generator circuit. B, a circuit for filtering two closely adjacent signals. C, automatic band switching circuit. Or D, a circuit for detecting FM signals.
Delta.
Delta.
Delta is correct, a circuit for detecting FM signals. How does a diode envelope detector function? A, by rectification and filtering of RF signals. B, by breakdown of the Zener voltage. C, by mixing signals with noise in the transition region of the diode. Or D, by sensing the change of reactance in the diode with respect to frequency.
Alpha.
Alpha.
Alpha is correct, by rectification and filtering of the RF signal. What type of detector circuit is used for demodulating single sideband signals? A, a discriminator. B, a phase detector. C, a product detector. Or D, a phase comparator.
Charlie.
Charlie is correct, a product detector. Okay, getting into some big sections here again with lots of questions. How frequently must an analog signal be sampled by an analog to digital converter so that the signal can be accurately reproduced? A, at least half the rate of the highest frequency component of the signal. B, at least twice the rate of the highest frequency component of the signal. C, at the same rate as the highest frequency component of the signal. Or D, at 4 times the rate of the highest frequency component of the signal.
Bravo.
Bravo is correct. At least twice the rate of the highest frequency component of the signal. What is the minimum number of bits required for an analog to digital converter to sample a signal with a range of 1 volt at a resolution of 1 millivolt? A, 4 bits, B, 6 bits, C, 8 bits, or D, 10 bits?
Delta.
Delta.
Delta is correct, 10 bits. What is the minimum detectable signal level for a direct sampling SDR receiver in the absence of atmospheric or thermal noise? A, sample clock phase noise. B, reference voltage level and sample width in bits. C, data storage transfer rate. Or D, missing codes and jitter. Correct answer is the Bravo, the reference voltage level and sample width in bits. What is dither with respect to analog to digital converters? A, an abnormal condition where the converter cannot settle on a value to represent the signal. B, a small amount of noise added to the input signal to allow more precise representation of a signal over time. Or C, an error caused by irregular quantization step size. D, a method of dissemination by randomly skipping samples.
Bravo.
Bravo is correct. A small amount of noise added to the input signal to allow more precise representation of signal over time. Hang on a real quick ticket. How many different input levels can be encoded by an analog to digital converter with an 8-bit resolution? A, 8. B, 8 multiplied by the gain of the input amplifier. C, 256 divided by the gain of the input amplifier. Or D, 256.
Delta.
Delta.
Delta is correct, 256. What is the purpose of a low-pass filter used in conjunction with a digital to analog converter? A, lower the input bandwidth to increase the effective resolution. B, improve accuracy by removing out-of-sequence codes from the input. C, remove harmonics from the output caused by the discrete analog levels generated. Or D, all these choices are correct.
Charlie.
Charlie is correct. Which of the following is a measure of the quality of an analog to digital converter? A, total harmonic distortion. B, peak envelope power. C, reciprocal mixing. Or D, power factor. The correct answer is A, the total harmonic distortion. What function is performed by a fast Fourier transform? A, converting analog signals to digital form. B, converting digital signals to analog form. C, converting digital signals from the time domain to the frequency domain. Or D, converting 8-bit data to 16-bit data.
Charlie.
Charlie,
Charlie is correct, converting digital signals from the time domain to a frequency domain. What is the function of dissemination? A, converting data to binary code decimal form. B, reducing the effective sample rate by removing samples. C, attenuating the signal. Or D, removing unnecessary significant digits.
Bravo,
Bravo is correct, reducing the effective sample rate by removing samples. Why is an anti-aliasing digital filter required in a digital discriminator? Digital decimator. A, it removes high-frequency signal components that would otherwise be reproduced as lower frequency components. B, it peaks the response of the decimator, providing it peaks the response of the decimator, improving bandwidth. C, it removes low frequency signal components to eliminate the need for DC restoration. Or D, it notches out sampling frequency to avoid sampling errors.
Alpha,
Alpha is correct. Well, that was a real tongue twister for a minute. I hate when you read something and then it just doesn't make that connection from here to here. SDR hardware, 4 questions. What is meant by direct digital conversion as applied to software-defined radios? A, software is converted from source code to object code during operation of the receiver. B, incoming RF is converted to a control voltage for a voltage-controlled oscillator. C, incoming RF is digitized by an analog to digital converter without being mixed with a local oscillator signal. Or D, a switching mixer is used to generate I and Q signals directly from RF input.
Charlie.
Charlie,
Charlie is correct. What aspect of receiver analog to digital conversion determines the maximum receive bandwidth of a direct digital conversion SDR? A, the sample rate. B, sample width in bits. C, sample clock phase noise. Or D, processor latency. The correct answer is alpha, the sample rate. Which of the following is a type of analog to digital conversion? A, successive approximation. B, harmonic regeneration. C, level shifting. Or D, phase reversal. Correct answer is alpha, successive approximation. Why would a direct or flash conversion analog to digital converter be used for a software-defined radio? A, very low power consumption decreases the frequency drift. B, immunity to out-of-sequence coding reduces spurious responses. C, very high speed allows digitizing high frequencies. Or D, all these choices are correct.
Charlie.
Charlie is correct. Very high speed allows digitizing of high frequencies. I and Q modulation and demodulation. 2 questions. What type of digital signal processing filter is used to generate an SSB signal? A, an adaptive filter. B, a notch filter. C, a Hilbert transform filter. Or D, an elliptical filter. Correct answer is Charlie, a Hilbert transform filter. What is a common method of generating an SSB signal using digital signal processing? A, mixing products are converted to voltages and subtracted by adder circuits. B, a frequency synthesizer removes the unwanted sidebands. C, varying quartz crystal characteristics emulated in digital form. Or D, signals are combined in quadrature phase relationship.
Delta.
The correct answer is delta. Signals are combined in quadrature phase relationships. Filters and impedance matching. 8 questions. Which of the following filters would be the best choice for use in a 2-meter band repeater duplexer? A, a crystal filter. B, a cavity filter. C, a DSP filter. Or D, an LC filter. 2-meter repeaters use cavity filters. Bravo.
Has anybody also referred to those as tank filters?
I've heard them called that too, tank filters. Although majority of the time I do hear it called cavities. That tuning to cavity, and I was always thinking teeth. Which filter type is described as having ripple in a passband and a sharp cutoff? A, a Butterworth filter. B, an active LC filter. C, a passive op-amp filter. D, a Chebyshev filter.
Delta.
Delta is correct. The Chebyshev filter has a little bit of ripple in the passband and a sharp cutoff. What are the distinguishing features of an elliptical filter? A, gradual passband roll-off with a minimal stop-band ripple. B, extremely flat response over its passband with a generally rounded stop-band corners. C, extremely sharp cutoff with one or more notches in the stopband. Or D, a gradual passband roll-off with extreme stopband ripple.
Charlie.
Charlie.
Charlie is correct. Extremely sharp cutoff with one or more notches in the stopband. Which of the following describes a receiving filter's ability to reject signals occupying an adjacent signal? A, passband ripple. B, phase response. C, shape factor. Or D, noise factor. The correct answer is Charlie, shape factor. Which of the following factors has the greatest effect on the bandwidth and response shape of a crystal ladder filter? A, the relative frequencies of the individual crystals. B, the DC voltage applied to the quartz crystal. C, the gain of the RF stage preceding the filter. Or D, the amplitude of the signals passing through the filter? Correct answer is alpha, the relative frequencies of the individual crystals. What is a crystal lattice filter? A power supply filter made with interlaced quartz crystals. B, an audio filter made of 4 quartz crystals that resonate at 1 kilohertz intervals. C, a filter using lattice-shaped quartz crystals for high Q performance. D, a filter with a narrow bandwidth and steep skirts made using quartz crystals. Correct answer is delta, a filter with narrow bandwidth and steep skirts made using quartz crystals. What is ringing in a filter? A, an echo caused by a long time delay. B, a reduction in high frequency response. C, partial cancellation of the signal over a range of frequencies. Or D, undesired oscillations added to the desired signal. Correct answer is delta, undesired oscillations added to the desired signal. How can unwanted ringing and audio instability be prevented in an op-amp RC audio filter circuit? A, restrict both gain and Q. B, restrict gain but increase Q. C, restrict Q but increase gain. Or D, increase both gain and Q.
Alpha.
Alpha is correct. Restrict both the gain and Q. Digital signal processing. 4 questions. What kind of digital signal processing audio filter is used to remove unwanted noise from a received SSB signal? A, an adaptive filter. B, a crystal lattice filter. C, a Hilbert transform filter. Or D, a phase inverting filter.
Alpha.
Alpha is correct, an adaptive filter. Which of the following is an advantage of a finite impulse response, or FIR, filter versus an infinite impulse response, or IIR, digital filter? A, FIR filters can delay all frequency components of the signal by the same amount. B, FIR filters are easier to implement for a given set of pass-band roll-off requirements. C, FIR filters can respond faster to impulses. Or D, all these choices are correct.
Alpha.
Alpha.
Alpha is correct. FIR filters can delay all frequency components of a signal by the same amount. What is the function of taps in a digital signal processing filter? A, to reduce excess signal pressure levels. B, provide access for debugging software. C, select the point at which baseband signals are generated. Or D, provide incremental signal delays for filter algorithms.
You know, you kind of give it away when you start laughing at the answers.
Yeah, that's true.
Delta.
That's great.
To provide access for debugging software. Reduce signal pressure levels. My goodness, where did whee! D is correct, or delta is correct. Provide incremental signal delays for filter algorithms. Okay, no more laughing. I gotta keep a straight face when I read these distractors. Ah, goodness. Which of the following would allow a digital signal processing filter to create a sharper filter response? A, higher data rate. B, more taps. C, complex phasor representations. D, double precision math routines.
Bravo.
Bravo.
Bravo is correct. More taps. Impedance matching, 7 questions, and we're doing good on time. We're almost done. Which of the following describes how the loading and tuning capacitors are to be adjusted when tuning a vacuum tube RF power amplifier that employs a pi network output circuit? A, the loading capacitor is set to maximum capacitance and the tuning capacitor is adjusted for minimum allowable plate current. B, the tuning capacitor is set to maximum capacitance and the loading capacitor is adjusted for minimum plate permissible current. C, the loading capacitor is adjusted to minimum plate current while alternately adjusting the tuning capacitor for maximum allowable plate current. Or D, the tuning capacitor is adjusted for maximum plate current and the load capacitor is adjusted for maximum permissible plate current.
Delta.
Correct
Delta.
answer is delta. The tuning capacitor is adjusted for minimum plate current, and the loading capacitor is adjusted for maximum permissible plate current. D delta. How are the capacitors and inductors of a low-pass filter pi network arranged between the network's input and output? A, two inductors are in series between the input and output, and a capacitor is connected between the two inductors and ground. B, two capacitors are in series between the input and output, and the inductor is connected between the two capacitors and ground. C, an inductor is connected between the input and ground. Another inductor is connected between the output and ground, and the capacitor is connected between the input and output. D, a capacitor is connected between the input and ground. Another capacitor is connected between the output and ground, and an inductor is connected between the input and the output. Visualize that. The
Delta.
correct answer is delta. Yeah, you have to, wow, really visualize that. Choose the right one. Which of the following is a property of a T network with series capacitors and a parallel shunt inductor? A, it is a low-pass filter. B, it is a band-pass filter. C, it is a high-pass filter. Or D, it is a notch filter.
Charlie.
Correct answer is Charlie. It is a high-pass filter. What advantage does a series L pi L network have over a series L pi network for impedance matching between the final amplifier of a vacuum tube transmitter and an antenna? A, greater harmonic suppression. B, higher efficiency. C, does not require a capacitor. or D, greater transformation range? Correct
Alpha.
answer is alpha, greater harmonic suppression. How does an impedance matching circuit transform a complex impedance to a resistive impedance? A, it introduces negative resistance to cancel the resistive part of the impedance. B, it introduces transconductance to cancel the reactive part of impedance. C, it cancels the reactive part of the impedance and changes the resistive part to a desired value. Or D, reactive currents are dissipated in matched resistances.
Charlie.
Correct answer is Charlie. It cancels the reactive part of the impedance and changes the resistive part to a desired value. Which describes a Pi-L network used for matching a vacuum tube final amplifier to a 50 ohm unbalanced output? A phase inverter load network. B, a pi network with an additional series inductor on the output. C, a network with only 3 discrete parts. Or D, a matching network in which all components are isolated from ground. Correct
Bravo.
answer is Bravo. A pi network with additional series inductors on the output. What is one advantage of a pi matching network over an L matching network consisting of a single inductor and a single capacitor? A, the Q of pi networks can be controlled. B, L networks cannot perform impedance transformation. C, pi networks are more stable. D, pi networks provide balanced input and output.
Alpha.
Correct answer is alpha. The Q of the pi networks can be controlled. Holy moly, look at that eye chart. 15 questions. And this is the last section. So 15 questions. Oh, we got plenty of time. How does a linear electronic voltage regulator work? A, it has a ramp voltage as an output. B, it eliminates the need for a pass transistor. C, the control element duty cycle is proportional to the line or load conditions. C, the conduction of a control element is varied to maintain a constant output voltage.
Delta.
Delta.
Delta, and this is the only time that they have the conduction. The conduction of a control element is varied to maintain a constant output voltage. What device is typically used as a stable voltage reference in a linear voltage regulator? A, a Zener diode. B, a tunnel diode. C, an SCR. Or D, a varactor diode.
Alpha.
Alpha is correct, our Zener diode. Which of the following types of linear voltage regulator places a constant load on the unregulated voltage source? A, a constant current source. B, a series regulator. C, a shunt current source. Or D, a shunt regulator.
Delta.
Correct answer is delta, a shunt regulator. What is the purpose? Oh, I missed another figure. What is the purpose of
Uh-oh.
Q1? Boy, we are just batting 1,000 here.
Charlie.
Charlie. Add diagram again. E7 DO6 power supplies. Correct answer is C. It controls the current supplied to the load. Oh man. Sorry. Too many. I need to watch for these crazy. Okay, what is the purpose of C2 and circuit shown in figure E7-2 is a bypass the rectifier output ripple around D1. Oh my goodness. What type of circuit is shown in E7-2? Linear voltage regulator. Okay. Thankfully, there's only a couple, and I just lost somebody because I didn't have that figures in there. Okay, he said no quality control. We're deleting this. What is the function of the pass transistor in a linear voltage regulator circuit? A, permits a wide range of output voltage settings. B, provides a stable input impedance over a wide range of source voltage. Or C, maintains nearly constant output impedance over a wide range of load current. Or D, maintains nearly constant output voltage over a wide range of load current. Correct answer is delta. Maintains nearly constant output voltage over a wide range of load current. What is the dropout voltage of an analog voltage regulator? A, the minimum input voltage for rated power dissipation. B, maximum output voltage drops when the input voltage is varied over its specified range. C, minimum input to output voltage required to maintain regulation. Or D, maximum that the output voltage may decrease at rated load. Dropout
Charlie.
voltage is Charlie. Minimum input to output voltage required to maintain regulation. Which of the following types of linear voltage regulator usually make the most efficient use of the primary power source? A series current source. B, a series regulator. D, a shunt regulator. Or D, a shunt current source. The most efficient use is a Bravo, a series regulator. What is the equation for calculating power dissipated by a series linear voltage regulator? A, input voltage multiplied by input current. B, input voltage divided by output current. C, voltage difference from input to output multiplied by output current. Or D, output voltage multiplied by output current.
Charlie.
Charlie is correct. A voltage different from the input to output multiplied by the output current. What is the main reason to use a charge controller with a solar power system? A, to prevent the battery undercharge. B, control of electrolyte levels during battery discharge. C, prevention of battery damage due to overcharge. or D, matching of day and night charge rates? The correct answer
Charlie.
is Charlie, preventing the battery damage due to overcharging. Match the day and night rates. Yep. What is a characteristic of a switching electronic voltage regulator? A, the resistance of a control element is varied in direct proportion to the line voltage or load current. B, it is generally less efficient than a linear regulator. C, the controlled device's duty cycle is changed to produce a constant average output voltage. Or D, it gives a ramp voltage as its output.
Charlie.
Charlie.
Charlie is correct. The control device's duty cycle is changed to produce a constant average output voltage. What is the primary reason that a high-frequency switching type high-voltage power supply can be both less expensive and lighter in weight than a conventional power supply? A, the inverter design does not require any output filtering. B, it uses a diode bridge rectifier for increased output. C, the high-frequency inverter design uses much smaller transformers and filter components for an equivalent power output. Or D, it uses a large power factor compensation capacitor to recover power from the unused portion of the AC cycle.
Charlie.
Charlie is correct. The high-frequency inverter design uses much smaller transformers and filter components for equivalent power output. What is the purpose of connecting equal value resistors across power supply filter capacitors connected in series? A, equalize the voltage across each capacitor. B, discharge the capacitor when the voltage is removed. C, provide a minimum load on the power supply. Or D, all these choices are correct.
Delta.
Delta.
Delta is correct. All of these are correct. What is the purpose of a step-start circuit in a high-voltage power supply? A, to provide a dual voltage output for reduced power applications. B, to compensate for the variations of the incoming line voltage. C, to allow for remote control of the power supply. Or D, to allow the filter capacitors to charge gradually. Correct
Delta.
answer is delta, to allow the filter capacities to charge up gradually. Dib, 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 dib. That's all, folks. Phew.
Ooh-wee.
Well, I got some severe editing on this one. Well, I think we need a new person to put these things together. Thanks for hanging in, guys and gals. That was
Thanks for doing it, Jim.
it was a ton of fun. Wow, that's the worst chapter I've done yet. Missing so many diagrams and complete chunks of wrong numbers. It was 108. That's what was really confusing me. It's just so many. Any questions or other thoughts on this section?
Well, a lot of those questions, you gotta really look for the most correct answer
Yeah,
or the
very
least
true.
incorrect answer. Some of those are kind of,
Yep.
Yeah.
Wow, we are getting close to the end. Closer to the end. Chapter 7. 27 pages. Test radio measurements and performance. Test equipment, receiver performance, and interference and noise. Yep. Alrighty. I didn't see Daniel. Daniel must have got caught out to work late. Good thing I didn't have a major question to answer. Yeah, this is definitely a learning process for me too. Like I said at the beginning, I somehow barely passed the extra, and I said, you know, with all of the changes since when I took it, I really want to redo it. And there's a lot of really cool learning stuff that is finally starting to sink in a little bit. Although you caught me on that NP0 or NPO capacitor, I must have, I don't know, too many things going on.
Negative, positive, zero, it says in the book.
Ah, good. Yep. All right, so chapter 7 for the next round. And if there's nothing else, we'll let everybody have half an hour back. Mike and Key general meeting is this Saturday if you're interested. We start out usually around 9:30 for our virtual coffee and donuts. And we're having, I forgot the guy's name, but it's solar stuff. So come
First
and
name's
join us
Carl.
on Saturday.
His first name's Carl.
Carl, yeah.
I don't know what his last name is.
K7LA. It was a long name with, oh, hang on. Got my email up just to go look at it.
Can't pronounce it anyway.
I actually kind of remembered how to pronounce it. Where to go? Groups IO, KRC. Oh, come on, I know it's here somewhere. Oh, I put it in follow-up, that's why. Carl
Lutzel Schwab.
Lutzel Schwab, K9LA, started his radio career shortwave listener back in the late 50s. Received his novice license in October 61 and started K9LA in 1977. He's a graduate of Purdue University and an RF design engineer until his retirement in 2013. He enjoys propagation, DXing, contesting, and experimenting with antennas and restoring vintage equipment. And he'll be talking about solar activity and propagation. Come join us Saturday. Oh, I forgot to turn off the recording. Oh well.